So in this example, in this clip, we're just going to look at a few examples of what we would regard as atoms, elements, and compounds, and use relative atomic masses to calculate relative formula masses or relative molecular masses, as the case may be. So we're just going to do a few examples just to show us how to use those numbers. So again, obviously we'll start with carbon. Carbon 12. This is the defining standard, and we know that for carbon, this is one atom of carbon, 1 mole of atoms of carbon will have a mass of 12 grams as defined by the mass number of carbon, which is 12. As I say, this is the defining standard of these. 12 grams of carbon will have 1 mole of carbon-12 atoms within it. Okay, and this is the relative atomic mass of carbon. Okay, so it's not a molecular mass because it's not forming a molecule, but this is the relative atomic mass for carbon-12, and it is 12, and it's equal to the mass number. You may see that abbreviated as RMM. Okay, now if we go on to the next one, we're going to look at hydrogen, and this is where, as I said before, formulae of compounds becomes of paramount importance, so the formulae had to be correct. Now, hydrogen is made up of 2 hydrogen atoms within the molecule. It's got 2 hydrogens within it. The mass number of hydrogen is 1. And so the relative molecular mass, this time, of hydrogen, so this is going to form a relative molecular mass. It's a terminology difference, but because we're forming a molecule, but this is going to produce a relative molecular mass, or RFM or RMM in this specific case. And relative molecular mass is used sometimes quite interchangeably. It may even be used for sodium oxide down there. And you may see a question, or someone may say, what is the relative molecular mass of sodium oxide? It's not a molecule, but sometimes it's used interchangeably, and probably a more correct term would be to use RFM, which is relative formula mass. So you'd work out the mass of the formula that you're given, in which case you don't have to be too precise. But with the textbooks, etc., you may see them used somewhat fluidly. But in terms of hydrogen, its mass, or its relative molecular mass, as a value, would be given as 2, and obviously grams, because we'd be weighing this out. And then if we just go through the remaining 3 examples, chlorine is made up of 2 chlorine atoms. The mass number of chlorine by the periodic table is 35.5. Not all mass numbers are whole numbers. Sometimes they're decimal points. Use whichever value is given on the periodic table that you're using at the time. For chlorine molecule, the relative molecular mass would be 71. Sodium oxide, 2 lots of sodium being 23 apiece. Oxygen, we'd have to add the oxygen. There's 1 oxygen being 16. So that will give us a total mass 46 for the sodium, plus the 16 is going to give us 62 grams. And then for the final one, water, 2 hydrogens, both weighing 1 each, plus 1 oxygen, still weighing 16, and that will give us 18 grams. So just a few examples of a way we can work out relative molecular masses, relative formula masses of the compounds, and the terminology that we would see, whether or not we see relative atomic mass, relative molecular mass, or sometimes interchangeably the relative formula mass of a compound as well.